everyone, welcome to the last lesson of Unit 2, Part 2. It's on page 186, and you will definitely want a pencil and a calculator handy. So, in lesson 13.2, we have here an isosceles triangle. And basically what an isosceles triangle is, by definition, is a triangle with at least two congruent sides. It's definitely something you're going to want to know and have in your notes. So it's a triangle with at least two congruent sides. Okay, we'll talk about that later. It's an important piece, though. We have a couple pieces of the triangle that we want to identify. The first would be the vertex angle. And the vertex angle comes between the two congruent sides. Okay. Now, the two congruent sides we call the legs. Okay. And the legs, again, are congruent to each other. And the base then is the bottom that is not congruent. And then we are also going to have two base angles, right, compared to the vertical angle, or vertex angle, excuse me. Now, what we notice about this is that it appears these base angles also are approximately the same size. And the reason we know this is because these guys coincide. If we folded this over like a line of reflection down the middle, what we would notice is it would reflect on top of itself. And we would say that it's kind of like a reflection. And we would see that these line up. So something that we can say is the isosceles triangle theorem, which is basically saying that if a triangle is isosceles, so it has two congruent sides, it's going to have two congruent base angles. Okay, so basically our base angles in an isosceles triangle are congruent, just like the congruent sides. Okay. Now, we'll talk about this later as well, but the converse of this will also be true, actually, in that if we have this base angle congruent, then we're going to actually also be able to say that our triangle is isosceles, aka the legs are congruent. So it kind of works both ways here, which we'll talk about later in the lesson as well. And now let's look at some problems, though, utilizing this. So if you look at page 187, they're telling us that we have an isosceles triangle with a vertex angle that is 80 degrees, okay? So something to be careful of here is always read if they're telling you specifically which angle is which, because we know that these guys are congruent, and if the vertex angle is 80 degrees, we want to know what's the measure of each base angle. So each base angle here has to be the same size. Well, using the information we talked about yesterday, if there's a total of 180 degrees in our triangle, we know that 80 plus our two base angles have to equal that measure. So if we subtract 80 from both sides, we know that the two angles have to add up to equal 100, aka they both, if we divide this by 2, have to be 50 degrees. Okay, so the measure of a base angle would be 50 degrees. Now, on the other hand, example 8 gives us an example where they're telling us about the base angle of the triangle. They're telling us one of the base angles is 25 degrees. Well, if this is an isosceles triangle, we know the other base angle also has to be 25 degrees. So this time, if we're looking for the vertex angle, same idea as the last problem, we know that they have to add up to equal 180 degrees. So if we subtract 25 and 25 away from 80, that's 50 total that we have to subtract. So 130 would be the value of that vertex angle. Okay. Now, down here, notice they are telling us this is an isosceles triangle because we have these two congruent legs here, which also means that these two base angles also have to be congruent. So even though they did not give it to us, we know that this also has to be 2x plus 3 because they have to be the same measurements, right? The base angles are the same. Well, now, very similar to what we were working with in part 1 yesterday with this triangle sum, we know that the vertex angle plus the two base angles, all three interior angles, have to add up to be 180 degrees. So as we try solving this here, we need to add these together, these pieces, to combine terms. So 3x plus 2x plus 2x, we have a total of 7x's. And then negative 1 plus 3 is 5. And as we start moving across this equal sign, we can subtract 5. We get 7x equals 175. And 175 divided by 7 is going to give us a total x value of 25. Okay, so that would be our value of x. So very similar to then what we were doing yesterday in this. Okay. Now at the bottom here, we have to, if they're saying an isosceles triangle is obtuse, that angle has to be the vertex angle. Is this person correct? Okay. Well, the answer here is yes. If we pick an obtuse angle like 120 degrees, we know that each of these can be 30 degrees. But if we have an obtuse angle and we try to make it the base angle of an isosceles triangle, remember these are isosceles, we know this would have to be 120 as well. Well, the problem here is this is too big. This is already 240 degrees. That's way bigger than the 180 degrees that we know this is. So we would have to make sure if they give us a vertex angle that's obtuse, it has to be the vertex angle. It can't be the base angle. Okay, so that's kind of a hint if they give you an angle and they don't tell you if it's the base or the vertex. If it's bigger than 90 or above, has to be your vertex angle. All right, now moving on to the next page then, last page of the notes here. We again talked about at the beginning the converse of the isosceles triangle theorem, that if we know we have base angles congruent, we also know that the sides must be congruent. Okay, so this is also going to be true. So when we start solving these problems, if we have two triangles, ABC, in a triangle, ABC, and they told us that angle A is congruent to angle C, we are now also allowed to assume, based on this converse of the isosceles triangle theorem, that these two sides are congruent. Okay, that's allowed. Now notice here they are talking about sides, not angles. This is talking about sides. There is no angle symbol to tell us that this is angles now. So we know that this has to be talking about the sides of our triangle versus the angles. Okay, so that's something that's really important as well. And as we label our picture here, we have side AB is 4x plus 25. Side BC is 2x plus 45. And then side AC down here at the base is 3x minus 15. Okay, now we want to determine the length of all three of these sides. Now, how we can solve for x to be able to plug back in is by setting the equal legs equal to each other. Okay, set those expressions equal. You do not want to involve AC quite yet because we don't know anything about how big AC is in respect to these two, but we do know they have to be equal. Drawing a picture is crucial here to know that information. So if we set those two legs equal, right, we have them to nothing to condense on either side. So I'm going to start by subtracting 2x. We get 2x plus 25. And then I'm also going to subtract the 25 from both sides to get x by itself. We get 2x equals 20. So x has to equal 10 here. Now notice what the question wants you to do though is find the lengths of the three sides. So if we plug this back in, 4 times 10 plus 25 is 65. So that's side AB. And then we know BC should be the same things. 2 times 10 is 20, plus 45 is also 65. And then last but not least, side AC, 3 times 10 is 30, minus 15 is 15. Which again makes sense because it doesn't necessarily need to be the same size since it was the base side. Okay, draw your pictures to help you see that information. Okay. Last but not least for today, number 17 here says, if we have an isosceles triangle, we said that it means it has at least two congruent sides. So using this definition, what other type of triangle is also going to be considered isosceles? Well, that's going to be an equilateral triangle. And the reason is because it has at least two congruent sides. It actually has three congruent sides. Okay? So whenever you talk about isosceles triangle properties, officially that also holds true for our equilateral triangles. Right? They're kind of, the special case as well because they have at least two sides congruent. They actually have all three, so they're also considered isosceles besides equilateral. Okay, we will definitely work more with this in class. Thanks for watching.